All right, ready, set, here we go. So going through these, when you solve these, you want to get y by itself, or whatever the variable is that to solve for by itself. And so problem number one, we subtract 2x from both sides. And some of you might say, well, why can't I combine the 20 and the minus 2x? It's because they're not like terms. You can't add or subtract them. So you just have to write it. So if you subtract 2x from both sides, it comes down. And then you can say, okay, I have 2y, and I'll divide everything by the 2, and then reduce. And so that was negative 2 over 2. That becomes negative 1, 10 over 20. Next one's pretty straightforward. Just subtract 3x from both sides. Y equals negative 3x plus 9. So again, you're moving things over the parentheses in order to get there. Problem number 3 starts out pretty easy. You technically could add 4 to the opposite side. So technically you have, at that point, solved for y. But in math, we don't like parentheses all that much, so you can distribute over the parentheses. So you get 1/2 x, and then half of 6 is 3. And then you have 2 like terms here to combine, so that just moves down to that. Okay, is there any questions up through the first 3? Anything that we did that doesn't look like it should be happening nicely? Problem number 4, yeah.
So for half times, when you do 2, because what I think I did this wrong. I multiplied 2 over 1 in number 3, and then I made that 1, and then I multiplied all of it.
So you had 2y minus 8 equals x minus 6. You're still getting the same answer.
Okay.
Because at the very end you'd have to go through and divide by 2 that was attached to the y, and your answer should be the exact same. Okay. Question 2.
For number 1, is it okay to have y equals 10 minus 6?
Oh yeah, the order is not horribly important to me. You will, when we start dealing with linear equations, want it written in that kind of order because that kind of clues you in how you're going to graph it. But if you had 10 minus x, dude, totally right. Cool? All right. Any other questions before I move on? So problem number 4, I subtract 3 from both sides, or 3x from both sides, excuse me. That gives me half y equals negative 3x plus 4. And then I'm going to multiply all 3 of those terms by 2, or 2 over 1, basically. And so that's going to give me y equals negative 6x plus 8. Is there a question? Yeah.
Oh, okay. So if you subtract 3x from 4, does it just stay the same as 4? Because it's not the same. Okay.
They're not like terms.
Okay.
Okay, number 5, subtract 2x from both sides. Then you have 4y equals negative 2x plus 8. And then you want y by itself, and 4 and y are being held together by multiplication. So divide all 3 terms by 4 and reduce. So then 4 over 4 is 1, so you get 1y, which is y. Negative 2 over 4 is negative 1/2. That's what we reduce it to. And then plus 8 over 4 is 2. Okay, and these are just more of a puzzle. And solving for this is kind of an algorithm of how you would undo stuff. Now, it's not the most fun puzzle on earth. I get you. I'm just saying that's what it really you're doing. Number 6, subtract 3x from both sides. Obviously, 18 and 3x cannot be combined. So you just have to write what you have. Divide everything by 9 and reduce. So 9y over 9 is 1y, which is y. Negative 3 over 9 is 1/3, so negative 1/3. And then 18 over 9 comes out to 2. Problem number 7, if you add 3 to both sides, you technically have indeed solved for y. And then you need to just distribute 1/3 over the parentheses. So 1/3 times x is 1/3 x. And then 1/3 times negative 26 is negative 26/3. And then I showed you that you can combine this up here. So you get negative 26 plus 9 over 3. That's negative 17/3. And so your answer becomes y equals 1/3 x minus 17/3. Okay, remember this is called the butterfly method when you do it this way. And 8, 9, and 10. So problem number 8, you just have to start someplace. We want y all by itself, so I think I started out subtracting 2y from both sides. And then I went, after that, subtracting 2x from both sides. And then here, God bless you, subtracted 5 from both sides. And then I divided everything by 2, giving me x over 2 is the same thing as 1/2 x. And then 6 over 2 is 3. Number 9, same way. You have to start someplace. So I'm just going to start by subtracting 4y from both sides. And then after that, I subtracted 4x from both sides. Added 11 to both sides. And then divided all the terms by 2 to get y equals negative x plus 1. And problem number 10, I think is the last one. Looks like I subtract 6x from both sides, and 12 and 6x cannot be subtracted from each other, so you just have to write them. Then I'm going to divide all 3 terms by negative 2 and reduce. So negative 2 over negative 2 is positive 1, so that's where the y comes from. Negative 6 over negative 2 is positive 3, and 12 over negative 2 is negative 6. And that's what we got there. Look good? Happy? All right. I have one thing to bring up. We're going to start going through, so we're warming up on these. So, solving for y. Talk me through it on that first one. I have 2x plus 4y equals 12. What's the first thing?
Minus 2x and then minus.
So, subtract 2x from both sides. I like it.
Yeah, okay.
Subtracting 2x from both sides. That cancels that. That leaves me 4y equals negative 2x plus 12. Is that okay? I want y all by itself. So what should I do to all 3 terms now? Divide everything by 4. Cool. So divide by 4, divide by 4, divide by 4. Reduce. Those cancel. That leaves me y equals. Negative 2 over 4 is negative half, right?
Yeah.
Negative half. And then the x comes along for the ride. And then plus 12 over 4, which is 3. Okay. That makes sense. Can I erase? Okay. That's the first one done. Next one, number 2, I have 3x minus 2y plus 6 equals 7x minus 3y plus 18. I want to get y by itself, so I'm just going to have to start someplace. So I think I might start with adding 3y to both sides. I think. If I do that, the 3x stays by itself. What's negative 2y added to 3y? 1y, which is just y plus 6 equals 7x. Those are gone now, plus 18. Okay? I want to start getting y by itself. So what might be the next thing to do? I now have y on the left side, but I have some other stuff. Subtract 3x from both sides. Cool. So that cancels that. So that gives me y plus 6 equals 7x minus 3x. That's 4x. What's left?
18.
Plus 18. How do I get y by itself now?
Subtract 6.
Subtract 6 from both sides. Good. Again, I'm just going to like term to like term. Those cancel out, so that gives me y is equal to 4x plus 12. Okay there? I like it. Can I erase?
I don't know, can you?
It's like when the
Student, hey, can I go to the bathroom? I don't know, can you? Yeah.
Because they're that teacher. Sorry about that. Like, just don't, you know what I mean.
I actually sassed one of my teachers for doing that.
You what's that?
I sassed one of my teachers for doing that.
You sassed him?
Yeah, he said, I don't know, can you? And I said, yes, I can, and then walked out.
I'll take it. I like it. Hey, number 3, I have x minus y. The whole thing's over 2 equals 6. So if the whole thing's over 2, what should I do to both sides? Was that party? Party's probably not the right idea, but if you guys want, I like parties. I like cake, ice cream.
2 over 1.
Yeah, multiply both sides by 2 over 1. If you do that, that cancels that, and that leaves me x minus y over 1, which is x minus y, equals 12. Okay, we have y here by itself, or y wanted to be by itself, so if I move the x over by what? Subtract it, good. So I get negative y equals negative x plus 12. I don't want to have a negative with the variable, so what should I do to everything? Multiply by negative 1. So if I multiply this by negative 1, I get? If I multiply this by negative 1, what do I get?
X.
If I multiply this by negative 1, I get? Negative 12. Done. Huh. Not too bad, is it? Yeah.
So,
So
does it matter if you have y equals negative 12 plus x?
I take negative 12 plus x. I like that. I think it's the same answer. These are we will eventually be graphing these. So when you have it set up this way, it's a way that we'll look at it to see, give you some information. But negative 12 plus x is totally fine. Yeah.
Wait, so are you saying that this is like set up to y equals mx plus b?
Uh huh.
Oh, okay.
But we're not there yet. But that's what we're getting to. No, it doesn't suck. Nothing to do with negative pressure. Okay, last one of the warm-up. I think it'd be easiest just to get rid of the parentheses, so I'm going to distribute over the parentheses. So if I distribute the 2 over the parentheses here and here, I'm going to get 2x plus 2y minus 6. Is that okay? That's going to be equal 5. I'm going to distribute what on this next one? Negative 3. Good. Don't forget the negative. That's where a lot of people make mistakes. So negative 3x plus 3y plus 2. 2. Combining like terms, let's see, on that side I have 2x plus 2y minus 6 equals, the 5 and the 2 can add together, so that's going to give me 7 minus 3x plus 3y. I want y by itself, so what should I do? Subtract 3y? Okay, I'll do that. So, seem to be trying to get it over here on this side, which is totally fine. That cancels that. That gives me 2x. It's 2y minus 3y. Negative 1y. Good. I think that's okay. What should I do next?
Add 6.
Add 6. Okay, cool. So that's 2x minus y equals 13 minus 3x. Okay, last.
Subtract 2x.
Subtract 2x, good. So that cancels that. So up here I'm going to get negative y equals negative 5x plus 13. What should I do to all terms?
Multiply by negative.
Multiply by negative 1. So this becomes y. This becomes 5x. This becomes minus 13. Done. All right, what do you think? We're okay? May I erase? We good? Anybody losing sleep over this stuff yet? I see numbers. You're doing a water drop.
Do that again.
Kind of push the air out of your mouth with your tongue. It's like, sweet. Don't tell your other teachers where you learned it from. What'd you learn in math class today? Oh, Mr. Sturp taught us this. I hate that teacher. What's funny is when you're in your science class, you start doing it, and the teacher starts going around adjusting the faucets. Anyone else hear that one?
Trapezoid in your cheek sounds like he's getting
Ready?
no. That's don't cut yourself.
Hey!
Not
We don't need that. All right, let's move on down. All right. Oh, literal equations. PV equals nRT. Speaking about chemistry, that's called the ideal gas law. Pressure times volume is equal to N, which is the universal constant, which is 0.0821, times R times T, the rate times T. It's the ideal gas law. N is a universal constant, which is 0.0821. I know this because I'm certified to teach all science too. So.
So,
All right.
wait,
yeah.
question, would I just do this just like any other problem?
How is P and V being held together?
Multiplication.
Multiplication. How's N, R, and T being held together? Multiplication. Does everyone feel okay with that?
Yes.
So, said no? Who said no? You with that? Oh, sweet. I want to get R all by itself. So R is over on that right side, and N and T are being multiplied. So what should I divide both sides by to get R all alone? What? N what? N and T. So I have PV equals nRT. I want R alone, so if I'm going to divide this side by NT, what I do to one side, I have to do to the other. So I find that R is equal to PV over NT. And guys and girls, that is a skill. If you learn how to do that, physics becomes real easy. Yeah. I'm telling you, it's great. Okay, problem number 2. Solving for D, we have W equals FD, so work equals force times distance. Love physics equation. Divide each side by F. I like it. F. So I'm going to get D equals, sweet. Now, what is D if W is equal to 20 and F is equal to 5? Oh. D equals W is 20, F is 5, which equals 4. 4 is equal to D. Sweet. Is that okay?
Wait, how did we get the numbers?
They gave us right over here.
Oh, I'm looking at another problem. Alright.
All right. Can I erase? I like it.
That sounds like Elmo. That's terrifying. Wow.
All right. I probably shouldn't do this, but I'm going to do it. Ready? What's your first name?
What?
What's your first name?
Me?
Yes. Crystal? Sorry.
Elmo by himself.
Did you do anyone else?
I'm so sorry.
You have to do a lesson like that.
You do anyone else?
Arnold
So you do
That's a fail.
I can imitate you pretty good, right?
That, like, I wouldn't want to
Talk a little bit.
No, but
Start talking.
Why?
It's a gift. I'm sorry.
Scary people, it's
Huh?
kids.
Did you do Peter Griffin?
I don't know who that is.
You're looking at?
That was
I didn't watch it. Sorry.
How about Ted? Have you seen Ted? Teddy bear.
Is this a really bad teddy bear that has to defend herself? We shouldn't, we're not gonna see it in class. We're not gonna see it in class. Arnold Schwarzenegger.
I have to listen to him a little bit before I can get it. He's not in my head.
Look up the thunder song.
I don't.
Oh, come on, you have the voice of Tom Kenny.
I'm telling you.
I think that would SpongeBob is so good.
It's so good.
SpongeBob, my little brother watches it like every morning.
And he should.
Oh my gosh. No, it's like I wake up and like I wake up.
All right, solve it for more stuff.
That's my
No more imitations. Ready? I want to solve for B1. Okay, so that is area equals base 1 plus base 2, all divided by 2, times height.
Wow.
So base 1, base 2, this is how you find the area of a trapezoid. A trapezoid is a triangle that you lobbed off and you have two parallel sides and you still have the corners like that. So you're like, what? It comes with geometry, don't worry about it. So if I wanted to get B1 by itself, if I wanted to get that B1 by itself, I think what I could do is I think I could divide both sides just right away just by h. I'm going to get a over h equals b1 plus b2 all divided by 2. Is that okay so far? So b1 plus b2 is all over 2, so how would I move that 2 over to the other side? Good. Times both sides by 2, or 2 over 1. I like it. So that's going to cancel that, and that's going to leave me b1 plus b2 over 2a over h. Okay. And I want b1 by itself, so b1 is added to b2, so how am I going to move b2 over? What do you think? No, not divide. How's b1 and b2 held together? Good. Subtract b2 from both sides. So subtract b2 from both sides. So I'm going to get b1 is equal to 2a over h minus b2. Okay? b sub 2, I guess we could say. So now, if b1, now what is b1 if a is 50, b2 is 10, and h is 5? Okay? So b1 equals 2 times 50, because a is 50, they tell us. H is 5, and b2 is 10. Oh, here's arithmetic. 2 times 50.
It's
100.
Isn't it minus 10? Because,
Yep,
yeah.
that is a minus 10. Good call, minus 10. 2 times 50 is 100. 100 divided by 2, or 100 divided by 5 is 20. 20 minus 10 is, so b1 is equal to 10. Sweet. Okay, almost done. Stick with me for a couple more seconds. Okay, volume is pi r squared height. Anyone know what that's the volume equation for?
Circles.
What? It partially circle. You're right there. Pi r squared. Cylinder. Good. Soda pop can. Can of soda is pi r squared height. Where r is the radius of the circle. Pi is roughly 3.14159, rounded. And height is how tall the can itself is. You had no idea you guys are walking into a little geometry today. It's horrible.
You try the circle thing.
What?
Do a circle and then tap the middle. Like when you're raising.
Like this?
That doesn't work.
It's because
It actually made a point.
So stupid.
we don't judge. Not the erasure. I understand. All right. Here we go. That's the last one. Solve for h. So pi r squared and h are all being held together by what property? Pi r squared and h are all held together how? Multiplication. So if I wanted to solve for h, what would I have to divide both sides by in order to get h all alone? If pi r squared and h are all being held together by multiplication, what do I have to do to both sides to get h alone? What? Pi r squared. What about it? Do what? Yeah, pi r squared. Divide both sides by pi r squared. Alright. Those cancel, so I get h equals v over pi r squared. Now, what is h if r is 2 and v equals 100 pi? Okay, so if v is 100 pi, okay, and r is 2, so if I plug 2 in, what do I get? Or if r is 2, what do I get? 4 pi. Wait, reduce, pi's cancel. 4 goes into 100, 25 times. So h happens to be 25. So you have something with a height of 25. A cylinder with a height of 25. Wow. Okay, we good? Everybody happy? Hey, this is what's going on. Hang on. I got a calendar here that I'm trying to stick by. I think we can do this. Okay, so we're going to do worksheet number 10. And because you guys are like the most awesome people I know, we won't have school on Monday.
I thought that's because
That too, but if I had the power to give you a Monday off, I would have given it to y'all. I do it again.
Technically, you could.
Then Tuesday and Wednesday next week we have reviews. And then we have another quiz on Wednesday. And then we get the exponent rules. And exponent rules, I like those. Those are my friends. Okay, worksheet number 10 sound good? It's literal equations. I think you guys are going to be able to do it. Talk to me. I got you, sister. All right, let's start saving this.